So yesterday we were discussing about surface tension. So today we'll discuss about some important concepts and try to solve some numericals. Okay. So we'll discuss about equation of continuity. Okay. So this equation of continuity is based on conservation of mass. Okay. Conservation of mass, and there are some conditions attached to it. So there are two types of flow. One is steady flow, one is unsteady flow. Okay. So let us say you have okay. Let us say you have some tube like this. Okay. So then tube like this. Okay. So let us say uh, so let us say you have some so you have some tube like this. So there is a flow. Okay. So uh, there so there are different flow lines. Okay. This is a line, this is a line, and this is a line. Okay. So what is a steady flow? What is a steady flow and what is a unsteady flow? There are two types of flow. One is steady flow, one is unsteady flow. Okay. So steady flow is the flow. Steady flow is the flow. If you take at any point, let us say at any point, okay, with respect to time, let us say let you consider 1 second, 2 second, 3 second, 4 second. You go and see this place, okay. At every 1 second, 2 second, 3 second, 4 second, at every point of time, the velocity remains constant. Okay. If that happens, then it is called a steady flow. So let us say at time t is equal to 0. Time t is equal to 0, my velocity, let us say t1. Let us say time t1 is equal to 0, my velocity v1 is equal to, let us say, 10 meter per second. Right? Then at time t1 is equal to 1, my velocity is equal to um, okay, let me say my velocity, only velocity. Okay, velocity is equal to again 10 meter per second. Okay, and at time t2 is equal to 3, my velocity is equal to again 10 meter per second. Okay, if the velocity remains constant, also you know velocity is not only a magnitude, it is also a direction. Okay, so if it is, let us say it is moving in the horizontal direction. Okay, so if it is moving in the horizontal direction at this point, let us say this point, it is moving in the horizontal direction, and at any point of time, if you measure like this distance, this to this, like it was here, now it is here. That is the velocity. Na? At 1 second, at 0th second, it was here. At the end of 1 second, it is here. So this magnitude is, let us say, 5 meter, 10 meter per second, right? And the direction is horizontal, right? It is horizontal here. But if you come to this point, okay, here maybe it can be 15 meter per second or whatever. It can be 15 meter per second, but the direction maybe it is inclined at 45 degree. Okay. So here also every time it will be 15 meter per second. Like time t is equal to 1, 15 meter per second. At time t1 is equal to 0, 15 meter per second. T1 is equal to 1, 15 meter per second. Like that. So every time it is 15 meter per second, and the direction is also inclined or whatever is the angle. So if this happens, it will be called as a steady flow. But what is a unsteady flow? The opposite of that is a unsteady flow. So suppose you say time t is equal to 0, it is 10 second, but it is completely horizontal. But let us say at time t is equal to 1, it is 10 second, but it is
not the same direction.
It is not. So if the magnitude has remained same, but the velocity has changed its direction. So velocity is combination of magnitude plus direction. So at the beginning of first second, 0 at the beginning, it is 10 meter per second horizontal. But at the next, time t is equal to 3 second, it is 10 meter per second, but it has changed the direction. Okay. So if the velocity, that means with respect to time, the velocity has not remained constant. Okay. And at the same location. So at any location with respect to time, if the velocity remains constant, it is called a steady flow. Then the reverse of it is unsteady flow. Because what will happen, like if in a steady flow with the help of a camera at any point of time, if you take a snapshot, it will look very like the picture will be combination of streamline. Okay, so you will see it. It will be, there won't be any intermixing of liquid.
It will be uniform.
It will be uniform. There won't be any intermixing. Okay, it will be like this. Let us say, and there will be streamlines. Okay, there will be streamlines, and there won't be any intermixing of liquid, right?
Yes.
In steady flow, there won't be any intermixing of liquid, because at every, like with passage of time, the velocity is remaining constant. So if you take a snapshot at any point of time, it will look the same. It does not mean that the velocity at different point in space is same. So at any point it is same. See, here it can be 10, here it can be 20. Right? So at all points the velocity is not same. At a given point the velocity is same. Okay. The velocity of a particular particle may change as it moves from one point to other. That is fine. So that is at some other point the velocity may have a different velocity. But every other particle which possesses the second point behaves exactly as the previous particle. So here also the velocity remains same. Here also the velocity same. It can be different. This can be 10, this can be 20. But here it will always remain 10, 20. At one point it will always remain same. Okay. So the particle follows a smooth path. So what you can see, the particle follows a smooth path. Let us say even the movement like this. Okay. This is also a streamline. Right? This is also a streamline. Because if you draw a tangent here, let us say you draw a tangent here, this is its velocity. Okay. But with passage of time, the velocity will always remain the same. But you imagine after some time, if the velocity becomes like this, it is not a steady flow, there will be intermixing of liquid. That will be unsteady flow. So here the particles, the path of particles don't cross each other. Okay. So you imagine that this path, and no other particle is crossing this path. Okay. So see, let us say it is moving like this. Let us say it is moving like this. So this, every particle has its own path. It will, because the velocity is not changing, if the path of each particle, no particle will cross each other's path. Okay. So this path taken by a fluid particle under steady flow is called streamline. So what is a streamline? So you can see that So this line is a streamline. What is streamline? Streamline
Line
means,
followed by the
yeah.
steady
So
flow
the path followed by the particle
in steady
in
flow.
steady flow. So first steady flow, then streamline. Two things here. Okay. So now we know what is steady flow. Steady flow is the flow where, with respect to time, the velocity remains constant
At a point.
at any point of, at any, two things here. One is spatial, one is temporal. Two things we say in physics. Okay, spatial and temporal. Temporal means time. Spatial means place. Okay, so here, with respect to space and time. Okay, at any given point, at any point of time. Two things. Okay, so at any given point, at any point of time,
Velocity.
if the velocity remains constant, that is called steady flow.
With direction.
Yeah, so it is constant with respect to time and space. If the velocity is constant with respect to time and space, that is called steady flow. Okay. And what is streamline?
Path
The
followed.
path followed by a particle
In
in a steady flow is called streamline. Okay. Okay. So here you can see, okay, here it is looking like a snake or whatever. So is it a streamline? One will get confused. But if you take a camera and at each point of time, if you measure and it looks like this, that means it is a streamline. Whether it is straight or whether it is curved or whatever. But if it remains constant, it is streamline. Okay. And in streamline, the particles of each particle's path don't cross each other. So that means there is no intermixing. There is no intermixing. So this has one velocity, this particle, this has one velocity. So they are not crossing each other.
Understood.
Okay, so what, now we'll get into what is equation of continuity. Okay. So equation of continuity comes from conservation of mass. Okay. So you know there are two things. One is conservation of energy. One is conservation of mass. So this conservation of energy, it will be useful in that Bernoulli's principle use conservation of energy. Equation of continuity is your conservation of mass. Okay. Let us take this picture itself. Okay. So this picture. Let us say this location is your P. Okay. Let us say this location is your R. Okay. P, R. Let us say this is your Q. These are three locations of this tube or whatever. Okay. So bring my glass. Let's see there where it is. Okay. So three location P, Q, and R. Okay. Okay. So let us imagine I have three cross sections. Okay. P, Q, and R. Okay. P, Q, and R. And the area of cross section at point P is AP. Okay. The area of cross section at point Q is AQ. The area of cross section at point R is AR. Okay. So these are three area of cross section. Okay. So there is some mass let us say, let me say it,
Which is point A?
no, no, A area. This is A is area of
Area
cross
into the
section.
side.
So area of cross section, area of cross section, area of cross section. Okay. So what is happening? Suppose if you take area at P, okay. So what is the mass entering? What is the mass leaving the cross section P at any point of time? What will be the mass? So mass is nothing but your area into velocity into density.
Density.
Because this is nothing but your mass flow rate. Okay, m dot we say mass flow rate is A into V into rho. Why? Because area you know is a meter square. Okay, your velocity is nothing but your meter per second, right?
Yeah.
So and density is your
Mass per
say
volume.
kg per
Yes.
meter cube. Right? These are the three units.
Yes.
Okay. So this becomes meter cube per second into kg per meter cube. Okay. Kg per meter cube. So this becomes kg per second. Okay.
Mass rate.
Okay.
Mass rate.
So mass flow rate. So conservation of mass means the mass flow rate at any point in a steady flow, steady streamline flow, the mass flow rate remains constant. That is equation of continuity. So that means that rho A, V, these three things it remains constant. Okay, so this rho A, V. Okay, what do you mean by V? That means suppose this is my cross section. So let us say how much is the mass of, so let me say my velocity, yeah. Okay, so the if you see like my velocity is this, okay. So my area of cross section is this, okay. So this area of cross section into this length, okay. So if I so how much and let us say so what will happen? So if you draw a, like if you want to see it is actually a volume, okay. This is the area of cross section
Into
and
light.
let us say this is my velocity. So this becomes a cylinder kind of, right? Right?
Yes.
It becomes kind of a cylinder, right?
Yes.
It becomes kind of a cylinder. So this will be like say this velocity is let us say 10 meter per second. 10 meter per second, right? Right?
Yeah.
This velocity is 10 meter per second and this is my area of cross section. Okay. So this let us say my area, let us say my area is say 10 meter, 2 meter square, right? Let us say my velocity is 10 meter per second, right? So and let us say my density is equal to water 1000 kg per meter cube, right?
Yes.
So the mass of, let us say this is all is at section P, okay?
Yeah.
So the mass flow rate, actually this is not mass, this is mass flow rate.
Okay.
So mass flow rate of liquid flowing through, let us say section A this is, flowing through section P is equal to mp dot is equal to 2 into 10 into 1000,
Yeah.
right? So this become say 2, 4, okay, meter cube, a kg, yeah, kg per second, right?
Yes.
So mass flow rate unit is nothing but kg per second. So so the equation of continuity, what does it say? The mass flow rate at section P, Q and R is same. Okay, you cannot create any mass or you cannot destroy any mass. Okay, so the mass flow rate mp dot is equal to mr dot is equal to mq dot. Okay, this is called the equation of continuity. So it will become like av into rho, sorry, velocity, right? So your area AP, velocity P, rho P, right?
Yeah.
Is equal to AR, velocity R into rho R is equal to AQ into velocity Q into rho Q, right?
Yeah.
So you know, like this density of water is an incompressible liquid. Okay, gas or air, they are compressible. Okay, because you know the atomic force depend on atomic force, the molecular force.
Yeah.
In gas or air, the molecular force is comparatively less, so you can compress it. Whereas water you cannot compress, water or oil or whatever. Those are called incompressible. So
Yeah.
these liquids are incompressible liquid. So this density in the flow, the density does not change. It remains constant. So if it is water is flowing, that means it will remain 1000 kg per meter cube throughout, right? So if that is the case, you can just cancel out this rho term. Okay. So that means your AP into VP is equal to AR into VR is equal to AQ into VQ, right? So this becomes your equation of continuity. So this kg per second, this unit AV means it will become meter cube per second. Right? That's all, meter cube per second.
Yeah.
So the volume pressure. So if the density remains constant, the volume flow rate remains constant throughout throughout the tube or whatever. The volume flow rate remains constant. Then that is called your equation of continuity. This is a very important equation in fluid mechanics. Equation of continuity. A1 V1 is equal to A2 V2 in steady and streamline flow. So what is a streamline flow? Or a steady flow?
Particles that follow steady flow.
The steady flow is the flow where the velocity remains constant with respect to time at a particular, at any point in the flow. So if the space at any point, the velocity remains constant with respect to time. So that is a steady flow, and the path followed by liquid, followed by any point in the
particles in
the path followed by particle
in
steady flow is a streamline. Okay. The path followed by a particle. Like say, so this particle it is following this path, it is following this path, it is following this path. Like at time t is equal to 0, it is here. At time t is equal to 1, it is here. At time t is equal to 2, it is here. That means at time t is equal to 3, it is here. Okay, so the path that is being followed by the particle is called a streamline.
Yeah.
Okay. Then this AB is equal to constant. This is the equation of continuity. Okay, AB is equal to constant. Okay. So a very important observation will come from this. Okay, suppose you have a pipe. Okay, so you have a pipe. Okay, so AB is equal to constant. That means if the area of cross section is high, okay, and let's see this. Okay, so that means A1 B1 is equal to A2 B2. Okay, let us say this is 1, this is 2. So here you can see that A2 is less than A1, right?
Yes.
If A2 is less than A1, implies B2 is greater than B1. B2 is greater than B1.
Yes.
That means if area decreases, velocity increases. This is a very, very important observation. Okay, if area decreases, this is A1, this is A2. So if area decreases, velocity increases. Okay, this is with this then we have now covered what is streamline flow. Then what is opposite of streamline is turbulent. Okay. Opposite of streamline is turbulent. Okay. So what is a turbulent flow? Okay. So this streamline flow happens only when the velocity is less. The velocity is below a certain level, then only streamline flow will happen. The velocity increases, goes beyond a certain level, it will become turbulent. Okay, so that is one point. Okay, so the speed beyond which the flow becomes turbulent is called critical speed. Okay, so okay, so when there will be intermixing of liquid,
Fluids.
then intermixing of fluid, it will become
Turbulent.
turbulent. Okay, so this will not follow this path. There will be the particles will cross each other's path.
Yeah.
Okay, in turbulent flow. Okay. So when this turbulence will occur, like say, suppose suppose in the flow, like you want to enter it, suppose your liquid is flowing, okay, all of a sudden it encounters some resistance, okay. If it encounters some resistance, there will be like kind of, so there will be kind of intermixing of liquid, okay. So there will be intermixing of liquid, and it can flow even in backward direction, like this it will flow. So there is intermixing of liquid, okay. So when you are the air is flowing, you put a body in front of it, so the flow will become it will become, all of a sudden it will become turbulent at that point of time. Okay?
Yeah.
Velocities are different. Okay. So it is very important, for example, in aircraft. Okay, in when the aircraft is moving. Okay, what is happening? Like, let us say this is, let us say this is my, okay. So let's say, let us this say this is my aircraft wing. Okay, this is my aircraft wing. Okay. So when my aircraft is moving at a velocity, let us say aircraft velocity. When it is moving, it is cutting the air. Okay. Like say, whether the air is like the aircraft is passing through the air at very high velocity. Let us see the aircraft velocity normally of this transport aircraft when we are going from Bhubaneswar to Bangalore or whatever. What velocity these aircrafts are moving? The velocity is around, let us say, 800 kilometer per hour.
Okay.
800 kilometer per hour. Okay, so this velocity these are all subsonic aircraft. I had told you that velocity of sound is something is around 1120 kilometer per hour. Okay, so velocity of sound is around 1120 kilometer per hour. So you know these trains are moving at how much? 100 kilometer per hour. Whereas your aircraft is moving at 800 kilometer per hour. Okay, but still it is less than the velocity of sound. That's why it is called, this velocity of sound is otherwise they call it as a Mach number. Okay.
Okay.
So Mach number is equal to 1. So what is Mach number? It is velocity of the aircraft divided by velocity of sound. Okay. So if your velocity of aircraft is same as velocity of sound, then we call it as a Mach 1. It is called as Mach 1. Okay. So these MiG aircraft, they are all supersonic aircraft. Okay. So their Mach number is something around 2.1 or so. That means they are
More
moving
than-
at 2000 km per hour or
More
2000
than
km.
speed of sound.
more than 2 times more than the speed of the sound. So in transport aircraft, there was only one transport aircraft which was supersonic. That was the Concorde aircraft. Okay, so there is hardly any supersonic air travel nowadays because that was just a fancy aircraft. It did not last long. Okay, because the fuel efficiency was too less for that particular aircraft. Okay, so the aircraft is moving at 800 km per hour, right?
Yeah.
So when your air is static, you are moving at 800 km per hour, right? So when you are moving at such a high speed, um, uh, the, like if you take a cross section, okay, let me say I'll take a cross section at this wing, okay. If I take a cross section, so if I take a cross section, it will look like an airfoil. So it will look like a airfoil, okay. The cross section is like this, okay. This is called a airfoil cross section. Airfoil cross section, okay. This is the airfoil cross section. If you cut the wing and it will look like, you cut it from here and look from the side, how does it look like? It will look like a airfoil cross section. So one will ask, if I cut it, if it looks like a rectangle, what is the problem? What is the problem?
It's the shape is not streamlined.
So if it is airfoil cross section, the flow will remain streamlined. So on the upper surface it will move like this, on the lower surface it will move like this. So there is a chance that it will maintain the streamline flow. But if it is a rectangle or so, it will give rise to, if you have these kind of sharp corners and all, it is called like kind of a block body. We call it as a block body or whatever. So there will be lot of intermixing of liquid and it will become turbulent. Okay. So to ensure that the flow remains streamlined, the best possible cross section is airfoil cross section. Okay, that's why we use airfoil cross section. So why do we using airfoil cross section? We want to maintain the flow as streamline. So why do we want to maintain it streamline? Because there is something called drag. Okay, drag means suppose you are moving there is air resistance. Okay, so if your shape is such that it is if it is so you might have seen the earlier days car. Okay, those are kind of like these Maruti 800 and all. They are not like you can see the modern days car. They are how is their shape, okay? So it is like Maruti 800 and all. If you take a cross section, it will be like a square cross section and all. So with this square cross section, the air resistance will be very high. It will not maintain a streamline flow. So in a streamline flow, the air resistance will be very less. Okay. Suppose the cross section is such a way that the air is flowing smoothly. Suppose I have a rectangular cross section. You see, this is a rectangular cross section. Air is coming. Okay. So if it is rectangular cross section, it will just the resistance will be too high. Okay. It will face the air and the resistance will be too high. But you imagine if it is a kind of aerofoil cross section, the air will flow smoothly. Okay. So on a streamline cross section, on a airfoil cross section, the air will flow very smoothly. So the streamline flow is maintained. But in a block body or a rectangular cross section or a square cross section, it will become turbulent. The friction will be less. So actually, when we are moving in the air, what is that? There is a friction with the air. Okay. So when we are moving very fast, the air also when we are moving, when you are running, you will feel that something is when you are going very slowly, you won't observe that. But when you are moving very fast, or when there is heavy wind, when there is heavy wind and you are running, you will feel that there is some resistance which is objecting you. Okay. So when you are moving at say 5 km or 10 km per hour, you will not feel that. But when you are moving like something 800 km per hour, you will see a lot of air resistance. The air is not going to allow you to move. Okay. So that friction or whatever resistance this when a body or the aircraft is moving through the air, whatever friction or resistance it is getting, that is called drag. But like when car is moving, you on the surface you are getting some friction. This friction is resisting, right?
Yeah.
Suppose your car is moving. If there is no friction on the road, that means the velocity will remain constant and you don't want, or you need not burn any fuel. At one velocity will go. But because there is friction, to overcome that friction, you have to maintain the constant velocity. You are burning fuel, right? You are putting force every moment, right? So, yeah. And so so to maintain streamline, when this airfoil cross section is used in aircraft, so that the resistance is less. Okay,
Yeah.
you always want that you will burn less fuel if the resistance to the
Is less.
flow of air is less. You will have to spend less fuel. You will be more fuel efficient. So that's why the airfoil cross section is the best cross section for aircraft wing. So there is a lot of research that has happened to develop this particular cross section. Okay, so this will ensure that the flow remains streamlined. So the flow will remain streamlined. Okay, the flow remains streamlined. If the flow is streamlined, then there is no intermixing of liquid and the resistance is much less. Okay,
Yeah.
so this resistance is this drag force is we'll study in Bernoulli's equation like half CD a v square. Okay, so this CD is a rho a v square. Okay, rho a v square. So this CD is nothing but your drag coefficient. Okay, so drag is what is the resistance force. See this in an aircraft. So in an aircraft there are, suppose this is my, okay, so in an aircraft there are four forces acting at any point of time. One is your lift. Okay, I'll tell what is lift. So why do we need lift? Because this weight always acts, gravity try to pull the aircraft downward. So you need to have a lift, otherwise how to balance it. And in the forward direction there is a force that is called thrust. So you have an engine. That engine, the jet engine works on the principle of Newton's third law. Okay, so because some gas is moving back at very high velocity, it will give rise to thrust. Okay, so this thrust, what it is overcoming? It is overcoming a drag. Okay, drag means this aircraft is moving at very fast, very high velocity, right?
Yeah.
So to maintain the velocity, see, it is to move at uniform velocity. You don't need additional force, right? Whatever force you are generating by the engine, that is just balancing the thrust. Balancing the drag. Okay. So to overcome the drag, you need thrust. That thrust is generated by the engine. Suppose you are moving at 800 km per hour. So that thrust, that you will have lot of resistance to it.
Yeah.
How much is that resistance? It is half CD rho a v square, right?
Yeah.
How it is being derived, don't bother about now. This is a frictional force which is called a drag force. So this drag force, this CD value will be very less.
Drag.
This CD or the drag coefficient will be very less if you have a aerofoil cross section. Okay. But in place of aerofoil cross section, if you have a rectangular cross section, this drag will be very high. That's why, so if drag is high, then you have to put a lot of force, you have to spend much more fuel to generate that kind of thrust. So for better fuel efficiency or whatever, like better fuel efficiency, so you want less and less drag. Okay. So to have less and less drag, you need to have turbulent streamline flow. So this streamline flow is maintained if you have a airfoil cross section. Okay. So this is about equation of continuity. Then we will do Bernoulli's equation. Okay. Okay. Let us do in the next session Bernoulli's equation.